All right. Welcome everybody to my talk, The 7 Tips to Pimp Your Git History. What I will be talking about have been covered so many times, and there are so many blog posts and conference talks about this topic, but I see so many experienced developers ignoring the simplest rules, and therefore I want to talk about this topic again. First, I want to introduce myself. My name here is written on the slide. I work for a company called Data Experts in Berlin, the wonderful capital of Germany. I'm in a team as a software engineer and architect. We work on an old legacy project. It's nearly 20 years old now. I'm the head of technology in my company, and I also contribute to open source projects. And yes, we also do some stuff with the HoloLens in our company. And I came up with this topic when I had a small JUnit test case. If you look at this small test class, this is a valid JUnit test. We have the first test that compares that 1 plus 1 is 2, and we have a second test that compares that 1 plus 1 is 3. Everyone sees that the first test should be green and the second test should be red. When we execute that in our favorite IDE, let it be Eclipse or IntelliJ or NetBeans or whatever, we get the expected result, 1 red and 1 green test. If we put this class into a Gradle build, we have also the same result, 1 green test, 1 red test. But if we put this class into a Maven build, the Maven build successful. No test failures. And when I discovered this, I didn't know that JUnit or Maven has some default values because it excludes these nested or inner test classes. The documentation writes about this. And if we look at the source code, we find this piece of source code that we exclude inner classes by default. We can configure that we want to have them maybe, but the default is we want to exclude them. But I didn't find a reason why it is a good idea to exclude them. So I searched through the documentation. I didn't find a reason. I searched through mailing lists or through maybe even Stack Overflow didn't have an answer on this topic. Okay, so if we can't find something on Google and nothing on Stack Overflow, we can use another great tool, which is called Git Blame. And we find the reason or the commit which introduced this default value. And it was the initial commit back in 2004. And the decision why these developers decided to exclude those inner classes by default is lost in time. So this is already my first tip. The initial commit, it should be as small as possible because everything that was before is lost. Because this commit message is not really helpful to others in the future. And this initial commit, this first one, should be as small as possible. And after that, we see how the code evolves, how the code changes, and we have commits that change and change and change. So if you start today or after you're leaving Devoxx with a new project, keep this first commit in your repository as small as possible. But how do we write good commit messages? First of all, you have to think about who is your reader of your commit message. And you should write not for yourself, but you should write for your reader. And I identified 3 different groups who you could write for. First, it's yourself. When you're committing your code, when you're done with your work, that you should reflect what you have done so far. The second one is the code reviewer that will review your code in a few minutes or in an hour or maybe tomorrow. He wants to see what you have done. He wants to see your thoughts, what you are trying to do. So he can see if the code changes are correct or if you missed some parts. And the third group is the poor developer that is on searching through the bugs in your code and want to see why is a piece of code like this. And he also uses git blame maybe and see this line was added with the commit, initial commit. And he curses and didn't know what were you thinking. So you have to be aware who is your reader of your commit messages. But let's take some examples. When I prepared this talk, I looked through my own code base and found some nice commits that I want to share with you. For example, this commit with a one-line change here in this if statement, this is the only change in the commit. A variable in an if statement was changed. So what is the best possible commit message for this? Obviously not this one. The developer decided to write fixed stuff. But he didn't write which component is involved, which use case. What was the, maybe is it an error he's trying to fix, or is he just fixing random stuff? Is it a good idea to change this? He just changed something and said, I fixed stuff. Maybe, yeah, that's correct. But we didn't know what he was trying to do. Then we have a text file with 4 lines added, nothing more. And what could that be for a commit? It's, of course, repair tests. Yeah, but which test case? Which test case was failing? And why is this a solution for this? And why was the test case failing? The developer didn't left us a hint what he was trying to do, why the tests were failing, and which tests were failing. And then we have some other nice commit messages. For example, some developers working on a new feature, and when they were done, they summarized everything they put everything in a new commit and wrote a nice commit message called triple mob programming, and it works. Hopefully. So they didn't write which feature they were working on. And they were only praising, let's hope it works. They are not really sure if it works as it should work. Then we have something like out of memory during processing, part 2. For me, this sounds like a horror movie. But what the developer was trying to do is really obvious. He was working on an issue which was about an out of memory that happened during the batch processing of some jobs. And the reported issue has a summary or title out of memory during processing. And we decided to split this issue into 2 parts. Part 1 and part 2, and he was working on part 2. And what he was trying to do, or what he have done, was just copy the issue title. But what was the out of memory? What has it changed? What was the previous error? Why was the previous implementation wrong? Why he thinks the new implementation is better? The commit message didn't help us. Okay, maybe we can find some other commits with some more details. I found this one. Okay, the formatting is not really good here, and there's no summary or something. It starts really with review. I think it is more consistent API. We just read all. Yeah, what are we talking about here? Which component is involved? Which use case? So this is something I would expect in every commit. I'm reviewing the API. something. So this is really a good descriptive message what has been changed here or what the developer was thinking. But there's no short summary. There is a default formatting for commit messages. If you type git help commit, it states that you should summarize your changes in a single line with around 50 characters. Then you should use a blank line, and then you can describe more detailed what you have done or some other things you want to leave to the future reader. And this is my second tip to you, that you should use this default format for messages. It is a short summary, a blank line, and the whole body for more explanation. This short summary is really important because no matter where you look into your Git repository, the summary appears first. You can look at the console, at the terminal. What you see first is the summary. You can go into your favorite IDE into the version control tab. And what you see first is the log, and what you see there is the summary. Or you can go to your web interface of your repository, for example at GitHub. What you see there is the summary of the commit. And if you don't use a short summary, different tools behave differently while interpreting this summary. For example, some tools just use the first line of your commit. And this is the first line, what you see here. It's not really summarizing what has been done in a small or in a short way. Some tools use everything until the first blank line. So if you have multiple lines, they are just joining all lines together and you have a even longer summary than before. Or other tools just cut off after maybe 70 characters, and this isn't even a good summary if you just cut at 70 characters. To conclude this, my next tip is just write a concise summary. It should maybe contain which component or use case is involved here. What is the content here? And if you are thinking, and you have to think about this before you write, and to get this into 50 characters. And when you are thinking, you maybe see, is this really one commit, or should this be 2 commits? Because we have some bug fixes and we introduced a new feature. So in one commit, this would be fix bugs and introduce feature ABC. Or if we have 2 separate commits, fix bug, introduce new feature. This would be a concise summary. Okay, but what about the rest? What the other stuff? What should we write in the explanation in the body? There's some, it depends. We should explain the old behavior and the new behavior, maybe, if you're, for example, if you're fixing bugs. What was the old, maybe wrong behavior? What is the new behavior which you think is correct? Which side effects do we introduce now? For example, if we add a new feature that is used now by default, for example, in batch processing of jobs, and there are some rare cases where this new feature isn't used, and those jobs in the batch processing now have a slower performance. That would be a nice side effect to mention. Then we have the changes that are not so obvious. These should be described as well. For example, if you remember this example with the repair test cases. This is a change that does not obviously belong to a commit that states repair tests? Why is this change of a text file belong to a commit that says repair tests? What you should also do is, if you are working on an issue, put a link to the issue in your commit message. You can just use the ID or the whole URL or maybe the full description. You should find a rule inside your team that you at least find a connection, a link between the commit and the issue. And if you have this, for example, at GitHub, in the commit, there is a nice little link to the issue, and at the issue, there's a link back to the commit. So you can see what have been done on this issue so far. And of course, if you're working with bugs, you search Google, and the first link is, of course, to Stack Overflow. And this is exactly the same bug you experience. And what we normally do is just copy the answer from Stack Overflow. Hopefully the answer, not the question. So it would be also a good idea to copy the link where you copied your code from, also into this commit message, so that other readers can see, this code was copied from this particular place. Maybe there was a nice explanation why this works or what you should be aware of when you use this solution. And last but not least, for the explanation inside of your commit message, you should answer why. Why is this change necessary? Why do we need to change this particular line or this particular component? Why did you change this with going the left way and not the right way? Why was the first implementation wrong? The answer to this question is interesting, maybe. But you should beware of why you changed the code. To summarize all these questions, what you should put in your commit message is something you want to keep everything that's inside your head right now when you're changing the code for your future reader. So you want to keep the context you're working on. So other readers can see what were your thoughts while working on this commit or on this particular issue. The next tip is something I experienced in legacy projects. For example, when you have not a really formatting rules. Sometimes I see commits where we have a one-line change and the developer says, okay, let's format all the code inside this file and commit all these code formatting changes, and we have 500 change lines, 499 are formatting issues, and 1 is the real change. If you are the reviewer of this commit, this is ugly. Don't do this at home. What you can try to do here, or what you can do here is partially adding files to your commit. This, I think you all know this. With the flag -p, Git goes through all your changes and asks you, should I add this change line to your next commit, or should I don't do this? And you have several options to say yes, stage this particular change, or no, or quit, I have done here enough, or add this particular change and all from the rest of the file, or not this change and no other changes of this file, or help. So if you have an old legacy code where there are, for example, no real formatting rules, this is quite helpful to have separate small changes in your commits. But this is helpful for other things. I recently worked at a feature where the result was nearly 700 lines new code and 600 lines deleted code, and I could put this in one single commit. I was adding a new feature. But I kept in mind that someone has to review this single commit, and when I have to review this by myself, so many changes, this is overwhelming. And what I did is I split it up in smaller commits. For example, I think it was a feature about refactoring 2 Boolean flag parameters and to introduce a third choice for something. And what I ended up with was some refactorings to get rid of these parameters. Don't worry, those commit messages are in German, but this not important here. But what I have done here was prefixing everything that was a refactoring explicitly with refactoring. So I can show to others I was changing the structure of the code. I didn't change the behavior, or at least I don't want to change the behavior. And at the last commit, I really implemented the new feature. What I try to say here is to make it easier for reviewers and for your future reader, you have to separate changes of your behavior or of a code from refactorings, where you restructure your code. So the reader can see in this particular commit, oh, here the commit or the code was restructured. There were no new behavior added or the behavior changed. Then I see sometimes commits with these here, add feature, or committed a missing file. Every time I see those types of commit, I know the developer doesn't know the flag git commit amend. With this particular flag, you can edit the last commit. You can add new files to this commit, or you can remove a file from a commit that you accidentally committed, or you can edit the commit messages. But you have to know that this flag exists, that you can edit the last commit in your branch. But you have to be aware of that you should do this only if the commit hasn't pushed to your remote server. If you do so, you have the old commit and a new commit. And this is even more confusing. And then we have something when you work in a big team with several features parallel in progress, then you end up with a commit history like this. I'm honest, I don't understand which commit is in which branch and which change is the red change yet now involved in green branch, and so I only can think, or I can only think in a linear way, but not in this tree form. And there's some other effect that could happen here. When you merge a branch into another branch, you can do whatever you want in this merge commit. A colleague of mine mentioned that you can replace your server with a pancake, and nobody will notice. Okay, they maybe notice that 2 days later, the project will not compile, but this will hide somewhere in those merge commits. Obviously, there is a solution for this, which is called rebasing. This does what the name said. It takes a commit or a branch and puts that on a new base, so that you can create a linear history, which is, for me, more easier to understand. But you can do even more with rebasing, which is called interactive rebasing, where you can reorder your commits in your branch, where you can delete single commits, where you can edit the commit message of commits, where you can separate one commit or split one commit into 2 commits, or where you can squash multiple commits into one commit, so that you can edit the history before you publish your branch to your colleagues or to the wide world. And what I have done here is, for example, while I was working on this feature, that I made some small save commits where I just wrote sloppy commit messages, for example, created the dialog or restructured the dialog. And after I was done with all these features, I came back to all these commits and rebased them first to the current master, so that I don't have this guitar hero we saw previously, but also to reword this and also to put new knowledge that I gathered during this working on this issue into older commits. This is also possible, and this is something you should also do. If you get new knowledge while working on an issue, you can put this new knowledge into older commits in your branch. And this is my tip number 7 to you. You should know and use the possibilities of interactive rebasing. And now that we have spent nearly 28 minutes about creating and shaping your commit history, about writing well-written commit messages, of structuring your commits, one option should you avoid from now on, and this is squash and merge. This destroys all the work we have done in the last 28 minutes. It takes all commits in your branch and put them together into one single commit. And this is not very good if you want to highlight maybe one single issue with a single commit where you only change 2 lines and have a big refactoring. Those are squashed together and all this information are lost. So to conclude my 7 tips, you should avoid this obvious, this big initial commit and keep this as small as possible. You should use the default formatting for commit messages: a short summary, a blank line, and the body. You should write a concise summary where the reader sees on the first view what the commit is about. You should keep the context of the commit so that you write as much as you know into the commit messages if you don't write that in the code. You should separate changes from refactorings. You should know that you can edit the last commit with git commit amend. And you should know and use the possibilities of interactive rebasing. I don't came up with this by myself. There are so many blog posts about this. Check them out, and these are my 7 tips to pimp your Git history. Thank you.